Okay, students, how are you doing? So, a very good afternoon to all of you. I have been receiving responses and I must say I'm happy about it, but I haven't been receiving response from everyone. So, kindly come on. It's time we do our work wherever we are in school or at home. Yes, since we are making the effort, come on, you can also do it. And I expect your work to be completed and sent it to me, okay, on my personal WhatsApp, because you're being graded on that. Let's start off with the next topic. Now today I'm going to take 7.2 and 7.3 together because it's a continuous topic. So it says the pH scale and indicator. Now 7.2, please check page 92, says is it an acid or an alkali? And 7.3 page 94 says the pH scale. Now, according to your learning objectives that we have to study, you have a few points that you must note. It says they explain the use of the pH scale and use indicators to distinguish acid and alkaline solutions. You have to know the pH of the solutions, use indicators to measure pH, understand concentrated and dilute acids. Now first I begin with, what is pH? You saw in the learning objective too many times this word pH has come. We have also seen whether it's the water that we drink, or sometimes we feel acidic if we've had something spicy, or when we have the lime or the lemon or anything that is sour, the tomatoes, we know that it is acidic. That's why we said anything that is sour is acidic. Now, here are a list of daily routine items or substances whose pH maybe until now you are not aware. But now let's look at it. So, you have the stomach acid. I'll start with stomach acid. In the stomach, you know the acid is hydrochloric acid. Now, this hydrochloric acid, the other day when I spoke to you, I said that hydrochloric acid, sulfuric acid and nitric acid are the inorganic acids that are found in the chemistry lab, and they are very useful. Now you can see that in our body also, in the stomach, whatever food we eat, that to be digested needs the acid, and that's hydrochloric acid. So what is the pH in our stomach? 1. Now we come to limes and lemons. It's at 2. Now this is a broad overview. Vinegar is a little higher, it's at 3. Now if you can see, as I'm going from my left to the right, look at the color changes. Then tomatoes are 4. Coffee is 5. So if you have too much of coffee, you know your system is becoming acidic, and that is not really good for our health. Now when it comes to milk, milk is also acidic, but it is not very acidic. You can see below 7 is written neutral. So this is a scale that is measuring acidic substances with acidic pH and with alkaline pH. At 7 we have water. Now just look at the bottle that you have, water bottle, and generally you will find that the pH written there is anywhere between 7.2 to 7.4. So it would be on the right hand side of 7, so it would be slightly alkaline. Now we come to blood, that's 8. Then baking soda, that's 9. And we have the ammonia solution, that's 11. Mostly the soups are around 12. The bleach is around 13. And the drain cleaner, any drain cleaner that we use is 14. So that's maximum on the alkaline scale. Okay. So what is the pH scale? As you know, we use a ruler or a scale to measure the length. This is a similar thing, but what is it measuring? It is measuring the pH. pH, or in other words, in the simplest of the words, is if a solution is acidic, or is it neutral, or is it alkaline. You can correlate it with when your car is standing in neutral, it doesn't move, nothing happens. When you move it to reverse, you go back, and then you can move it in front also, so it is driving. So you are just changing. That's the pH scale. I'll keep explaining and things would be clearer as we move on to the next slide. Now, if I have to find out the pH, when we have to find out anything, we need an indicator. Again, I'll go back to the example of the car. If I'm going straight, okay, no problem, I'm in my lane. Now, if I want to change my lane to the right, I will give the indicator to the right, correct? If I have to change my lane to the left, I will put the indicator to the left. What do you mean by indicator? Indicate means to show. Now, here in chemistry, an indicator is a substance that shows different colors. Now, how do we know that, okay, this is red or this is blue or this is green? It's just the color. So, it shows different colors in acids and in alkalis. There are many indicators that are made from the normal fruits or, the vegetables as you see. So you can have it from red cabbage juice or from black currant or from beetroot. Okay. Now I'll just give you an example. If you are cutting the small pieces of red cabbage, and you can look into page number 93 into that activity. Hopefully when we get back, I will do this activity with you so that we prepare our indicator solution, because here we need something that is called the methylated spirit, because the color doesn't dissolve in water. It dissolves in an organic solvent, and only then we can prepare it. Okay, but here look, for the red cabbage, it's pink in acid, it's blue when it is neutral, and yellow in alkali. So if you are using red cabbage as the indicator, and if the liquid turns blue, what is the pH? It is neutral. So neutral means 7. If you are using red cabbage and if the solution turns pink, then it's acid. Acid means any number less than 7. So from 0 to 6.9 is acidic. If it changes to yellow, it becomes alkaline. Now, there are other indicators which are generally more commonly used for qualitative analysis and the neutralization reactions in chemistry, and that is litmus. What is litmus? Please refer to your page number 92. Now, litmus is a very common indicator. What happens here? It turns red in acids, blue in alkalis, and purple in a neutral substance. Okay, we just saw for red cabbage, it was pink, blue, and yellow. Here it is red, purple, and blue. Now these difference in the colors, please, it may seem a little confusing, but concept is the same, that there is color change when there is a shift in the pH. So, if you are using litmus, then it would change to red if it's acidic. It would be blue if it is alkaline, and it would turn purple if the substance is neutral. Okay, now the litmus color change. Here, I have taken the chart from your book. So let's see the substance, that is hydrochloric acid. In litmus color, it's red. Type of substances, it is acid. Sodium hydroxide is an alkali. So the litmus color is blue, and what is it? It's an alkali. Water is purple, and the type of substances, it is neutral. Lemon juice is red, and the type of substances, it is acid. Again, calcium hydroxide, you can see sodium hydroxide and calcium hydroxide, both of them are blue because both of them are alkaline. Okay. Now, this is just a simple pH scale and the color. So the scale ranges from 0 to 14 and you have 1, 2, 3, 4 and you just look at the color from red to orange to yellowish. The color gets lighter, then shades of green, blue and then it goes to purple. Here again, if we look at universal indicator, that is the second most common indicator which is used here. At neutral, let's start at 7. That's neutral. If we move to the left, you can see 6, 5 and 4. If you have any liquid which has the pH of 6 or 5 or 4, we say they are weakly acidic. There can be points also. So 7 to 6, it has 6.1, 6.2, 6.3 until 6.9 and 7. Okay, this is how it goes. But this is a simple one for you as of now to understand. And on the left hand side further, as you go down towards 0, it becomes strongly acidic. So as I'm moving away from neutral, the acidic property increases. As I'm moving away on the right hand side, the alkaline property also increases. Now, so if it is strongly acidic, UI is universal indicator. If it is strongly acidic, then the color is red. If it's weakly acidic, it's yellow. If it's neutral, it's green. It's weakly alkaline, it's blue. And strongly alkaline is purple. Now, please understand that the choice of an indicator, that is whether we wish to use a litmus as an indicator or we use a universal indicator, there are many other indicators like methyl orange, there is phenolphthalein, okay? Then any of these indicators, we have a chart that is designated. You need not get scared. You don't have to remember for all of them, but just these three, that is red cabbage, the color change, for the litmus, the color change, and for universal indicator. So if you get to see, now hopefully when we get back, I will let you find out the pH of the different things that we use, you know, in our daily lives. So whether it's the tap water or it's your drinking water or it is your toothpaste or it is your soap or any of the product that we use, we'll do it as a project and experiments, okay, in the class. It's not very difficult. So 7.2 questions, question 1 to 5 and 7.3, 1 to 6. It's weekend, you have 2 days and I want you to finish these questions. Please write the answers beside the questions, send me a screenshot, okay, with your name on my personal chat. I would be more than happy to help you, okay. Come on, please. I want to see a much better response from next week. Thank you. Have a nice weekend. Stay safe, stay healthy, be happy. God bless.